Alright, hello everybody. This is going to be a overview of the practice midterm 1 from fall of 2009. This is now the spring of 2021, so I guess stats doesn't really change, but it doesn't really matter. Okay, right off the bat, question 1, pretty easy. Which of the following sets of 4 numbers has the largest possible standard deviation? We can rule out D just because it's all the same. C is just, distance of 1. B is just a distance of 1. A clearly has the largest spread between the data. So in this case, that's going to make that correct. It is going to be A. Question 2, what interval on the horizontal axis corresponds to the middle of 50% of the area under the standard normal density curve? So on a normal density curve, that looks like this. Let me do some drawing here real quick. Looks like this. That's not bad. And then, so basically, 50% is represented by an area kind of like that. We'll say that. So if this whole area represents 50% of the data, then that means this area is 25% and this area is 25%. So if you want to find the values, now since this is a standard normal curve, let's start from there. And a standard curve, your mean is 0 and your standard deviations are 68, 95, 99.7 and correspond to values rating from negative 3 to like positive 3 or something like that. So one standard deviation is going to be that 0.68 number on the interval. So to find the 50% range where there's 25 on each side, you can just find the z-score for the value of 25 and basically 75% of the data. The easiest way to do this is just to do inverse norm in your calculator. If you don't know what inverse norm function is or how really to do any of the stats functions on like a TI-84, I'm gonna put a video in the description or it might pop up at the top. If you know how to do the functions, it'd be a good refresher. If you don't, you definitely need to be able to do that because it saves you a ridiculous amount of time. So in this case, it's just going to be inverse norm of 0.25, which is going to give you that'll give you what, like negative 0.67, and then inverse norm of 0.75 because that's 75% of the data, and then 25% of the data. It's just going to give you the same number but positive 0.67. So that interval is going to be here because on a standard normal density curve, these z-score values are going to be associated with the actual standard deviations themselves because it's just 1 and 2 and 3 and -1, -2, and so on. So that is that. Question 3 is a stem plot of the data, roughly symmetric, but the data do not even approximately follow 68, 95, and 99.7 rule. So the 68, 95, 99.7 rule is basically normal distribution. So if it doesn't follow this rule, then it's not normally distributed. So you can just rule out the fact that it's normal. So no, 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 and it's not standard. So it's just not normal. It's just as simple as that. It's not normal. All right, question 4. Which of the following is most likely to have a mean that is smaller than the median? So if you have a mean that is smaller than the median, that means that the data is going to be skewed. So in this case, it was going to look something like this. So you're going to have like a couple values down here, and then the rest of your data is going to be like 79, there's going to be a big quantity of data that is in this upper region, and so you're going to have a lot of big numbers and then a couple small numbers. So which one of these answers corresponds to that? That's going to be D, because out of students, On a very easy exam, most score well, that's represented by this, but a few do poorly. It's going to make your median is going to be in the middle, like it usually is, but your mean is going to be skewed to that side. To that side because you have those few lower numbers. Question 5, the following density curve to answer that question. Now, this doesn't look like a curve, does it? No, it's not. It's just kind of, I can't really think of a scenario where you'd have a data set that looks like this, but basically imagine that you have data where like your input variable is like 0.5 or 1 or 1.5 and 2, and somehow you always get the fact that each one of those data points gives you 0.5, 0.5, 0.5, 0.5. So it's just a square. And so for the purpose of this question, what percent of the observations lie between 0.25 and 1.2? So what percent lie between this point and like here somewhere, right? You can just find the distance between this, which is just going to be 1.2 minus 0.25, which is just going to be 0.95 out of the total. So 0.95 out of 2, which is our total, is just going to give you 0.475, which is going to equate to 47.5%, which is our answer A. Let me do that in gray to be consistent here. All right, question 6. So a sample was taken of the salaries. Okay, it doesn't really matter. Okay, so you have 2 different changes to this data set here. The first change is that let's just say the first change is that every employee is getting a $3,000 raise. So in this case, the entire data set is just going to be moved up by $3,000. So the entire data set, all the values, everything is just going to be moved up. Not standard deviation, because standard deviation is just a measure of the distances between things. But if everything is moving in a same direction by the same amount, the standard deviation is not going to change because the distances between those values haven't changed. So the next thing is 5% increase. So at a 5% increase, the employees who make like $20,000 a year in a strictly monetary sense by a dollar value are going to have a smaller increase than the employees who are making more. Oh, I just dropped my pen. They are making more money per year, and so it's going to skew the data in a direction that is not going to be static in each way. So the upper ranges of this data are going to spread farther apart, and the lower ranges are going to spread apart, but just not as far as the higher ranges. So the standard deviation is also going to follow suit and is going to increase by 5%. All right, so question 7. Let's see. The most striking feature of this plot is what? So the fact that y is categorical. Y is not categorical. It is quantitative because it is numerical. So it's not categorical. That's not the answer. There are many outliers evident in the plot. I mean, let's see. There's really not. I mean, you look at this, that's pretty solid. So no outliers. The granularity, I don't really go to lectures because I don't know, it doesn't really seem to help. But granularity is basically the fact that all of these are in little chunks. So chunk, 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 chunk. That's what it means when the data is granular. Another way to interpret granularity is like as a category. So like you can have granularity, and then in granularity you have like it's coarse, or it can be like fine, meaning like you have like big chunks like this, or you can have fine where it's like little chunks like this. So that's the difference. But I don't think this is really what he's talking about. I think he's talking about like just chunks in general, the fact that they are chunked at all. Chunk, I'm using that word chunk a lot, chunk. So the data is granular. It's not skewed, so I mean it's pretty solid there. So C is your answer for that one. 8, the mean cholesterol levels of 10 men who visited a cholesterol screening clinic located in downtown area is 250. So the mean of 10 men, your mean is going to be 250. They found out that one of them reported a level of 280, but it's actually 230. So they reported a level that is 50 points higher than it should be. So what you can do is just find the total value of all the points added up for the original 10 men. So that's going to be 2,500. And then, excuse me, you can just subtract the excess cholesterol of 50. So minus 50, and that's going to give you 2,450 as the total, and then you can just divide that by 10 men, which will give you a new average of 245, which is your answer B. It's pretty easy. Question 9. So in this question there's 2 different histograms that it gives you. They're the same data, just the top one has smaller intervals than the bottom one. And the question is asking you what percent of the schools have an acceptance rate under 20%. So basically what you can do is, well, first you have to consider the fact that it tells you that in each interval the left endpoint is included but not the right. So in the interval, just to explain what that means, in this interval right here, between 20 and 25, it includes the left endpoint, which is this one, in the fact that so from 25 and beyond, this endpoint right here is included. So what it's saying is this entire chunk doesn't represent 20, it represents 25. So if you want to find the people who have a rate under 20, you're going to have to look at this chunk right here and this chunk right here. And this chunk right here is 3, this chunk right here is 1. That's a total of 4 schools who have acceptance rates less than 20%, and it tells you that the total is 25. 4 out of 25 is what? 16% equals 0.16. So your answer is going to be C, 16%. 10. The Highway Institute publishes data. What is the interquartile range? So you can do this by hand, and I guess for the point of this video, I will do it by hand just to kind of, well, you know what, actually screw that. No, I'm not doing it by hand. I mentioned the video that you can watch. I'll link it again right here to show you all the calculator functions for basically stats in general. Like, I mean, it's a super help. I don't think he's really mentioned it in the lectures from what I'm hearing. So look at that video and it'll show you how to do it. In this case, we're not going to use inverse, so if you were to technically figure this out with your calculator and use individual functions, you can basically just divide your crap up into 25, 25, 25, and 25, and you want to find Q1, Q2, and then Q3. You don't need to find Q2 because that's your mean, but you basically need to find your value for Q1 and Q3, and then you're just going to do Q3 minus Q2, and that's going to give you your IQR. And you can do this just by finding the z-score for this value, which is just going to be negative 0.67, and this one's going to be positive 0.67. You can find that using the inverse norm function of 0.25, which will give you this, and then you can do of 75, and that'll give you this one, because you're saying that 25% of the data, and then you're getting 75% of the data within the first one. And then you can just use your your formula to find that. But then you'd also have to find the standard deviation, which is just annoying. So the way I recommend doing it, go in your calculator, go to stat, make a list, put these 4 values into the list, click on your one variable statistics, calculate it, and it just gives you Q3, it gives you Q1, which is 900 minus 700, which is just 270, yeah, 200. So C is going to be your answer for that. There's really no need to overcomplicate that, just learn the calculator function, you'll be fine. 11, reporter wishes to portray baseball players as overpaid. Which measure of center should you report as the average salary for major league players? So if you want to show that baseball players are overpaid, you have to find a measure of center that is affected by a heavier outlier on the top end. So median is not going to be affected by that. It's always going to be the center of the number of data points that you have. Your mean is going to be it can be skewed by that. So if you're trying to show that the players are overpaid, you want to use the mean, because this is your median. You want your mean is going to be like up here. What is that symbol? Looks like that, the mu thing. So B. 12. The time to complete a standardized exam is approximately normal with a mean of 70% or 70 minutes, excuse me, and a standard deviation of 10 minutes. Using the 68, 95, 90.7 rule, what is the percentage of students that will complete the exam in under an hour? An hour being 60 minutes. So just draw our curve here. Well, and that's not very symmetrical, but it is what it is. It's telling us that one standard deviation is 10 minutes on each side. So if our mean is 70, one standard deviation is going to be 60 minutes, which so happens to be our cutoff point for what we need. So we just need to find the percent of students who will be in this range. So if this range, because it's one standard deviation away, this is going to be 80 minutes. We know that using the 68, 95, 90.7 rule, this whole thing represents 68% of the data. On either other side, 100 minus 68 is 32. So both of these, both of these sides added up is going to give us 32. So that means this side is going to be 16% of the data, which also is our answer. 16% of the data is under the 60-minute mark. B is our answer for that. 13. A small business has 30 workers, 2/3 of which are female. The average salary of all female workers is $40,000. Average salary of all male workers is $45,000. What must be true about the average salary of all workers? So if you have 30 workers and 2/3 are female, that means you have 20 female workers and you have 10 male workers. Let's see, how would I go about doing this? Basically, I guess you can just find the total combined, payment of salary for all the workers, basically by saying, okay, let's find the total for the average of females. Females is 20 people times 40,000 is going to be 800,000. And men with a salary of 45,000 is, there's 10 of them, so that's 450,000. So that plus that is 1,250,000 divided by 30, which is just 4,166.66. So this is your average of all your workers, and it's not going to be 42.5. It's not going to be any number between 40,000 and 45,000. It must be larger than the median salary. What is the answer here? I don't even know. Let me check the answer key to make sure I'm doing this right. 13B. Okay, so yeah. So it's not going to be larger than the median salary. And so, I mean, we just calculated it, so the answer is just going to be B. So that's the answer to that one. 14, a set of data has a median that is much larger than the mean. Which of the following statements is most consistent with this information? So when you have a median that's larger than the mean, that means that there are going to be higher values associated at the left side of your median. So that's your median, this is your mean. This is an interesting example, but that basically means your data is skewed to the left. That doesn't mean, so skewedness is based off of the chunk of the data, not the tail of the data. So that's just something to think about. It's based off, it's not the tail. Just remember that. 15, a soft drink. Let me know where's the question. 15, a soft drink machine can be regularly regulated so that it discharges with an average of that ounces per cup. If the ounces of each discharge are normally distributed with a standard deviation of 0.4 ounces, what value should mu be set at so that 6 ounce cups will overflow only 2.5% of the time? Alright, this is a difficult question. So basically, I think what it is asking is if you have a distribution here that looks like this, right? And you want the cups to be set so that at 6, so you have to use the z formula for this. So the z formula is just z equals x minus your mean over your standard deviation. You're going to plug in a value of 6, not for your mean, but that is going to be the value that you want to find 2.5% of the things will be over. So that I didn't explain that very well, but basically here's how you're going to set this problem up. You want to find 6 minus some value where the standard deviation it gives you is 0.4 at 2.5% of the time. So 2.5% of the time you want to find your z-score that equals that. So you want to find your z-score for the data that is here. So this is your 2.5% that is wanting you to make sure it only overflows that much time. So you need to do inverse norm, or that's what I'm going to do. You can look at the table, but I'm just going to do inverse norm of 0.975 because that's what 100 minus 2.5 is, which gives you a z-value of 1.95996. So that's your z-value, and then plug that into here and do some math. So you're just going to multiply that by 0.4, and then you're just going to subtract 6, and then you're just going to negate the whole thing because you have a negative x. So it's going to give you 5.216, which is going to be rounds to 5.22. So that's how you set that problem up. 16, a company produces packets of soap powder which are labeled giant size 32 ounce. The actual weight of soap powder, gosh, we've been doing this for a long time. Soap powder, standard deviation of 0.7, 95% of the packets contain more than X ounces of soap powder. So in this case, let's draw it out. It wants you to find that this is 95%, so this must be 5%. It wants you to find this value here, basically what size of packet is the breaking point between 95% and the rest. So once again, use our z formula. We're actually going to do inverse norm of 5% this time because we want to find this level here. And that's going to be equal to negative 1.64485. And then we're going to set up our formula where that equals x minus 30, let's see. It gives us that 33 ounces is our mean with a standard deviation of 0.7. Do some math, and it's going to give you a value of 31.849, which rounds to 31.85. That is the cutoff point for the packets that contain more than X ounces of soap powder. 17. The weights of packets of cookies produced by a certain manufacturer have a normal distribution with a mean of 202 grams and a certain standard deviation. So this time it wants you to find the standard deviation. The weight of the packets is lighter than 196. So it's saying, okay, 2.5%, which we'll use our inverse norm to find that. It is going to be, I'm not even going to write it out, negative 1.95996 equals 196, which is our x minus our mean, 202, over our standard deviation, which we'll just denote as x at this point. And then you're just going to solve for x, which is just going to be, I guess I'll just do it. So x is going to be equal to 196 minus 202, which is just negative 6 over negative 1.95996 is equal to 95996 is just going to be equal to 3.010612, which is close enough to 3. So that's the standard deviation of this function here. Okay, so honestly, I don't know how to do 18, so if anyone wants to help us out with that, that'd be great. 19, you want to find the IQR based off of the fact that the score is normally distributed with a mean of 100 and a standard deviation of 15. So what you want to do is you just want to calculate your Q1 and your Q3, and you can do this with your mean and standard deviation by just using your Z formula. So you want to find this point here and this point here. To do that, your Z scores for both of these is just going to be negative 0.67 and positive 0.67. We found this earlier based off of an inverse norm of 25 and of 75. And so you're just going to plug in your Z formula. Z, both of these are going to go in there, equals x minus 100 over 15, and then you can just do some math. So negative 0.67 times 15 plus 100 is 110.05. So Q3 equals 1. Q1 is equal to negative 0.67, 89.95. Subtract the 2 and you get 20.1. So that's going to be your IQR of these scores here. 20. Least squares regression line is, so your least squares regression line is going to be the line, so the sum of the vertical distances. So your vertical distances, it's C. Like I don't even need to explain this. If you don't know how to do this, you can probably look it up somewhere else and be a better explanation than I can do it. 21 A researcher wishes to study how the average weight y in kilograms of children changes during the first year of life. The intercept of the least squares line is. So to find the intercept of a least squares regression line, you need to find the slope first. And to find the slope, you can do the standard deviation of y, which is 1.2. 1.2 over standard deviation of x, which is 3.6, and you multiply that by your r value, which it conveniently gives you as 0.9. And so that is going to give you a value of 0.3, which is your slope. And to find the slope, what you're going to do is you're going to take your mean of your y values, so 6.6, and you are going to subtract that from the your slope, which is 0.3, times the mean of your x values, which is going to be 6.5. And that is going to give, so the formula is basically y hat is equal to, mean of your y minus your slope, which is, I think is that R0? I don't know, whatever, or B0, whatever one it is, your slope, times your mean of x. That's your y formula, and that's going to give you 4.65. That is the intercept of your least squares regression line. Further problem above, the slope is, we already calculated that, 0.3. 23. Suppose, using the same data, the researcher wishes to predict the children age from their average weight. This means needs to fit a regression line to the data with y as the explanatory variable, as x as a response variable. So in this representation here, your explanatory variable is currently your age. So age is the explanatory variable and weight is the response variable. So in 22 it's saying flip that. So the slope is just going to be flipped, so it's just going to be 3.6 over 1.2, which is going to give you 2.7, a slope of 2.7. I hope this was somewhat useful. I've kind of gotten tired here at the end and my throat hurts, so sorry for going too quickly or just skipping over some completely. Also, if anybody knows how to do 18, let me know. Thanks.